not, is, in. These are used for logic and for comparisons. Conditional keywords. Those are if, elif, else. These are used for decision making. Looping keywords. For, while, break, continue, pass. These are used for looping and flow control. Exception handling. These are try, accept, finally, raise, assert. These are used to manage your errors. Functions and scope. Def, return, global, non-local. These are used to define your logics. Oops and classes. Class and delete. These are used in object-oriented programming. Modules and imports. Import, from, as. These are used to import your libraries and comes into boolean and null. True, false, none. These are used for logic values. Context managers and generators like with, yield. These are used in file handling and generator functions. Async programming. Async and await, where you are going to use for concurrency. Together these 35 keywords define the entire grammar of Python. Why keywords are needed? Imagine writing a story with no grammar, just random words. That's what Python would look like without your keywords. Keywords make code structured, readable and predictable. They tell Python where conditions begin, where loops run, when functions start and when execution stops. Keywords are like Lego connectors. Without them, your colorful blocks that your ideas have no way to stick together. Let's go for other example for try accept. Using try and accept. Now give try x equals to 10 divided by 0. Then accept zero division error. Now let's print. Oops, division by 0. Sorry, by 0. Let's close the brace. And now let's finally print execution complete. Let's close the brace and let's run the output. Oops, division by 0 and we got execution complete. So here we are going to see the try. If there is an error in try, then on it is going to print accept. And then whether we have an error or not, it will print finally block. So here 10 by 0 we have an error. So we are going to print the accept block, which is oops, division by 0. And finally it is going to print the finally block, which is execution complete. So now let's see class defining. So let's see defining a function. So now let's take def greet of name and return. Use formatting string f hello, comma, open the curly brace and name and just close that. And let's print the statement. We have to follow the proper indentation here. Greet of the name we have to give here, which is, let's give Python learner. Let's close the brace and let's run this. Yes, you got hello Python learner. So here we have created a function, name is greet, and instead of that we have given a name parameter. So instead of that name we have returned hello, it has to print hello with the name. So we have given the name which is Python learner. So now we got the output which is hello Python learner. And let's create a class now. Class in action. Now let's create a class. We have to give class keyword and the class name which is car. Now we have to define a function def and now double underscore init double underscore. We have to open the brace self parameter along with the brand and now close colon follows the indentation self dot brand equals to brand car equals to, so let's follow the indentation again. So let's create an object now car equals to now car of the brand Tesla. And now we'll print car dot brand. So now let's see the output Tesla. So here we have created the car with the car class. Inside of that we have created a function which is the brand. So self dot brand equals to brand. So here we have to give the brand. So we have created object which is car. In that car we have stored the car class and we have given the brand name which is Tesla. Now if you print car dot brand, so it will gives you the Tesla, the brand name. So we have seen how the keywords naturally tie everything together. Now let's create a mini projects. Now let's create a mini project of calculator. Let's take a comma b equals to 10 comma 5 and now op equals to input enter operation open brace plus minus multiplication division. Now let's close the brace. Let's give colon. Let's close. Let's give colon and let's close the brace again. Now if op equals to double equals to plus, then print a plus b. Elif op equals to minus print a minus b. Elif op equals to multiplication star, then print a into b. Elif op equals to division, then print a divided by b, else print invalid operator. Now let's run. So here we have to enter the operation. So let's enter anything. I have given plus. So it has given 10 plus 5 which is 15. If you give minus, it will give 10 minus 5 which is 5. And If you give multiplication, it will give 10 into 5. So I have given plus, so it has given a plus b. If you give minus, it will do a minus b. If you give multiplication, it will do a into b. And if you give division, it will do a by b. And if not, if you give any other operator than plus, minus, multiplication and division, then it will print invalid operator. So now again just run. So now if you just give division, it will give invalid operator because we haven't given any percentage here, right? So it will print invalid operator. Let's type while true, password pwd equals to input, enter password. If length of password is greater than equals to 8, print strong password. Then break and give else, print too short, try again. Here your password should be greater than or equals to 8 characters. Try again. Now let's run. So here we have an invalid syntax error, which is greater than equals to 8. So we should not give the space between that. Yes. So now let's type any password. ANABSINGH@123. It's a strong password because it is greater than or 8, right? So we have given the true condition and we have to enter the password first. So the condition is if the length of the password is greater than or equals to 8, it has to print strong password. Else it has to print too short, try again. So now let's run again. If you just give any nina, it is less than 8 characters, so it will just give you too short, try again. Now if you run again, you have given nina sing. Now it is a strong password because the characters are greater than 8. Now let's take an example for file reader. Let's give try with open. R with open data.text as F, print F dot read, except we have to follow the indentation. Just don't forget that. File not found, error. Print file not found. Just close the brace. Let's run. So we got an error which is file not found. Why? We are going to open which is data.text, and if it is there, it is going to read. If the file does not exist, then it has to print file not found. So here the file does not existed. So let's create the file here. Hello Python. Now go to the file, click on save as, just give the file name which is data.txt. Now let's name as already data1 is there, so let's give data2.txt. Now just save. Now let's minimize this. Now let's run this. Just refresh. And here we have the location of that, the data to txt. So just copy that and just paste here. If it is giving file not found, then we have to give the path here. So let's give the path. So now we can see we got hello Python, right? So we have given the R here, which we are going to mention that we are going to read that file. So then it has readed that data2.txt which we have created in our notepad, and now we got an output which is hello Python. So this is how you are going to use your keywords. So here we have used keywords are try, with, as and except. So these are the keywords here. The common mistakes that we will do. So these are the mistakes that we should avoid are using keywords as variable names, forgetting the colon after if, for or while. Confusing is with double equals. Messy indentations, because Python is very strict. So fix this early and your Python journey will be smooth. Here are the interview questions. First one, why can't keywords be used as variable names in Python? Here is the answer for you. Because keywords are reserved words with predefined meaning that define Python's grammar and behavior. Second question, what is the difference between keywords and identifiers? Here is the answer for you. Keywords are fixed by Python, while identifiers are user-defined names for variables, functions, and classes. Third one, why is indentation important when using keywords like if, for, or while? Here is the answer for you. Because Python uses indentation to define code blocks instead of braces. Fourth one, what role does the finally keyword play in exception handling? Here is the answer for you. It guarantees execution of cleanup code regardless of whether an exception occurs. Fifth one, why does Python include only 35 keywords despite being a powerful language? Here is the answer for you. To keep the language simple, readable, and easy to learn while still being expressive. So let's recap what we have discussed in today's video. So keywords are reserved words with predefined meanings, and you cannot use them as your variable names. They are grouped by purpose like logic, for loops, functions, classes, async, and even more. So without keywords, Python is just a plain text. With keywords, it becomes logic, intelligence, and structure. In our next video, we'll dive into functions in Python, where keywords like def, return, and global truly shine. We'll build reusable logic, explore parameters, and even learn how functions talk to each other. So, if you learned something new today, hit that like button, subscribe to SP Learning Labs, and share this video with your coding friends. Remember that Python doesn't just run your code, it understands it thanks to keywords. And keep practice, stay curious, and I will see you in our next session. Functions in Python, your first real step into reusable code magic. Keywords and Libraries Part 2. Hey everyone, welcome back to SP Learning Labs. Today, we are unlocking one of the biggest reasons why Python dominates artificial intelligence, data science, automation, and web development because of libraries. These aren't just files or folders. Libraries are power boosters for your Python. With just a single import, you can perform tasks that would normally take hours or even weeks to code from scratch. By the end of this session, you will understand what libraries are, how to use them, how to install them, and how they save you massive amounts of time, turning you into a faster, smarter Python developer. In our previous video, we explored Python keywords, the grammar and building blocks that shape your code. Now, we shift gears from Python's language rules to Python's superpowers, the ready-made tools that help you build apps, analyze data, scrape websites, automate workflows, and even train AI models. Welcome to the world of Python libraries. What exactly is a library? Think of a library as a toolbox full of pre-built tools. You no longer write every single function by yourself. Python gives you shortcuts. For example, import math and boom, instantly hundreds of mathematical functions are unlocked. If keywords are alphabets, then libraries are entire dictionaries of ready-made wisdom. They turn Python from a simple language into a full engineering toolkit. Analogy: if keywords are alphabets, then libraries are entire dictionaries of ready-made wisdom. They turn Python from a simple language into a full engineering toolkit. What is a library in Python? A Python library is simply a collection of modules, and each module contains some reusable code. Libraries are designed for specific purposes. For math operations, web APIs, artificial intelligence and machine learning, file handling, automation, data processing, and much more. Example: import random. Print random.randint from 1 to 10. This one imports saves you from writing your own complex random number generator. In simple words, libraries are pre-written solutions to common problems. Library versus module versus package. These terms confuse many beginners. So, here is the simplest explanation ever. Module: a single .py file with code. Example: math.py. Package: a folder containing multiple modules like NumPy or Pandas. Library: a collection of related packages or modules. Python standard library. Analogy: library, the entire bookshelf. Package: a single book. Module: one chapter in that book. This structure helps Python stay organized and scalable. Why Python libraries are important? Python rose to fame largely because of its libraries. They allow you to save weeks of coding, write less and build more. Simplify extremely complex tasks. Use optimized industry-tested code. Build faster and more reliably. Follow industry standards used by big tech companies. Examples: NumPy, Pandas, data science, Flask, Django for web development, TensorFlow, PyTorch for AIML. Request for API communication. OpenCV for computer vision. These libraries transform Python from a simple language into a global technology powerhouse. Why we use libraries? So hi, this video is Keywords and Libraries Part 2. So now let's see why we are going to use these libraries and how we are going to import your libraries and how you have to manipulate the data. So now let's have a quick Python demonstration of that. So let's start. So just open your Jupyter notebook, just go to the file and go to the new and notebook. So I want to give the file name here. So I just want to give module 3.2. Now let's rename. Yes. So I want to now let's give libraries. So let's compare manual logic versus library power. So let's zoom that you can see the screen well. So I want to give a command. Let's give command now. Which is the manual logic versus library power using the manual method, which is a square root function. So now let's take an example. X equals to 9 exponentiation 0.5. Now using library method, now import math. Now print math dot square root sqrt of 9. Let's close. Now let's run. So we got 3.0. Forgot to give the print function here, print of x. You can just see here x value 3.0 and the value for library is 3.0. Here we want to see how we are going to use a manual method. Using manual method, normally we have given a function which is x equals to 9 exponentiation 0.5, which means we get 3.0. And using library, we have given import math. Here math is a library and we have printed math dot square root of 9. Here square root of 9 is 3. So 3 square is 9. So we have got the output which is 3. So this is the difference between manual and using a library. How libraries are used? Let's see how to import and install libraries. Importing. Example, import math. From math, import square root. Import numpy as np. You can import the whole library or only what you need. Installing external libraries. Pip install numpy. Pip install request. Pip install numpy equals to. Always use virtual environments so that each project keeps its own clean set of libraries. Python standard libraries. The built-in modules. Python ships with a massive standard library, which is powerful tools included by default. Here are some essential library. Purposes: math, mathematics and formulas. Date time, for dates and time handling. OS, for OS level operations. System, for system control and configuration. Random, for random operations. JSON, for JSON parsing. Collections for advanced data structures. Regular expressions for regular expressions. Iter tools for iteration utilities. If Python were a smartphone, the standard library would be your built-in apps like camera, notes, clock and calculator. Everything ready from day one. Random password generator. So let's give import random. So we have to import the modules first, right? Next, import string. Now let's take a variable chars equals to string dot ASCII underscore letters plus string dot digits plus, and we have to give the characters, special characters, exclamatory, at, hash, dollar, percentage, and now password equals to quotes dot join of random dot choice of chars. So we have to give the condition for I in range of 10. Now print double quotes generated password and now we have to call the password. Now close and let's run. So we got generated password is we have got, right? So here we have imported the random module and we have imported the string. So now from that string you want to call only the ASCII letters and the digits, and now you have given the special characters. So including that and letters and digits, we want to create a random password which should be generated by random. So system wants to generate a random password for us. So that's what we have done. Let's take a second example, second demo on file creation and deletion with OS. Now let's import operating system first. Now with open sample.txt, now write W as F. Now f.write hello spill. Now let's give print statement. File exist. Now os dot path dot exist. We have to give the file name, which is sample.txt. Now os dot remove, we have to give the file name inside of braces sample.txt. Now let's run. Yes, file exists, which is true because we have a file which is sample.txt which is already existed. So for that it has given true. So here now f dot write hello spell means it will just write the hello spell. So if the file exists, then it has to print true. And after that it has to remove the sample.txt. So if the file exists, it is true. Now let's take in another demo, which is handling JSON API response. We know API means application programming interface, which is used to connect both front-end and back-end, right? So now let's give import JSON first. Now API response equals to, let's open a dictionary now, name colon, now alias, let's give the role as AI engineer. Next, data equals to JSON dot loads of API response. Now print data of name. We have to give minus within double quotes, comma, data of role. So we want name, hyphen and role. Now let's print. So we got the name, which is alias, and the role AI engineer. So loads is going to convert your string. So this is what about the file creation and deletion with OS, and these are all the examples of keywords and libraries. So this is how we are going to use the libraries. Here are the common mistakes that every beginners make. So don't do this again. First one, trying to import a library before installing it, using a wrong aliases, mixing Python 2 and 3 versions, installing libraries globally instead of in a virtual environment. Fix this early and your Python workflow stays smooth and clean. Here are some interview questions that you have to prepare before going for an interview. First one, what is a Python library? Here is the answer for you. A library is a collection of modules containing reusable, pre-written code designed to solve specific problems. Second one, how is a library different from a module and a package? Here is the answer for you. A module is a single .py file. A package is a folder of modules. And a library is a collection of related packages.
Hey everyone. Hey everyone and welcome back to SP Learning Labs. Today we are covering one of the most powerful topics and widely used patterns matching tools in Python, regular expressions, commonly called as regex. Regex helps us validate data, extract information, clean text, search logs and process messy input. It's used heavily in backend development, data engineering, NLP, automation testing and web scraping. Analogy. Think of regex as a magnet, but instead of attracting metals, it attracts patterns. Want phone numbers? It pulls them out. Want emails? It finds them in a second. Dates, IDs, repeated words, regex pulls exactly what matches the rules and you define. In the previous session, we mastered functional tools. Regex naturally fits into the next step. Before processing the data, we often need to clean it, validate it, or extract meaningful patterns. That's exactly Regex helps us to do. Introduction to Regex. Regex is a pattern language used to search, extract, validate, and clean text. Python provides the capability through the built-in RE module. Import RE, literally matching re.search for the cat is here. Meta characters that helps Regex. Dot, any character. Asterisk, 0 or more. Plus, 1 or more. Question mark, optional. Square braces, character set. Open braces, capturing group. A straight line for OR. A cap for start and a dollar symbol for the end. Examples, we'll see it now. If we take re.search, this matches cat, cot, anything that is provided in the brackets. Regex is not about matching letter. It's about matching patterns. Pattern matching and special sequences. Regex provides shortcuts for common categories of characters. Special sequences. /D indicates for digits. /word indicates for alphanumeric plus underscore. And /S for white spaces. /D, /W and /S for opposites. We'll take re.findAll to find all these in a pattern. If a cap pattern starts with it, it indicates match at the start. If the pattern starts with cap, it indicates matching at start. If the pattern ends with dollar symbol, it indicates that matching at the end. We'll see quantifiers. If 3, then we'll need exactly 3 to draw from the pattern. If indicates 2, 5, then we'll draw the patterns from 2 to 5. And if it indicates 3, colon, we need to extract at least 3 from the pattern. Groups, name groups and back references. Groups allow us to attract specific parts of a pattern. Basic groups. Name groups. Back references, used when the value must repeat. /1 refers to the first captured group. Look aheads and look behinds. Look arounds check what comes before or after a match without including in it. Positive look ahead. It is followed by a digit. Negative look ahead. Negative look behind. Look arounds validate surrounding context without consuming characters. Substitutions and real world use cases. Regex is extremely helpful for cleaning and transforming text. Replace digits. Remove extra spaces. Standardize date formats. Remove HTML tags. Extract emails. These patterns are commonly used in web scraping, from validating and data processing. Common errors that we face. Forgetting raw strings. Always use r/n instead of r/quoted n. Greedy matching. Dot and star matches too much. Use non-greedy versions. Dot asterisk with a question mark. Confusing search with match. Match only at start. Search anywhere. Catastrophic and backtracking. Patterns like A plus of plus causes excessive matching attempts. Misusing character sets. A to Z means literal dot. Alone dot means the character. Never mention facts. Regex is a tiny programming language. Python requires fixed with look behind. Dot use do not match. Refines unless dot all is used. different languages have different regex engines. re.compile improves performance in product. Regex can be faster than loops for pattern-heavy tasks. Regex is used in parsers, compilers, NLP tools and log analyzers. Now we'll see a tricky question. Does dot match new line? Only with dot all. Difference between search and match? Match starts only and search anywhere. Why is dot asterisk dangerous? It's greedy. Does Python support variable length look behinds? No, it doesn't support. What does start and end defect? It indicates an empty line. Now we'll see a few interview questions. What does /d match? Yeah, digits 0 to 9. What is name group? A group with a label using P and name. What is look ahead? A condition that checks what follows a match. We'll see greedy versus non-greedy. Greedy matches as much as possible, but non-greedy matches as little as possible. Match versus full match. Full match matches an entire string. How to replace text using regex? Use re.sub. You can replace everything. What is back reference? Reusing a previously captured group. Which module handles regex in Python? re.e. Purpose of compile. Pre-compiles a pattern for faster repeated matching. Let's recap. And that completes our regular expressions. You now understand pattern matching, groups, lookarounds, substitutions and the key pitfalls to avoid. In the next video, we'll move into virtual environments and package management, an essential part of structuring real-world Python projects and managing dependencies the right way. If you like this session, like this video, share and subscribe to SP Learning Labs. Virtual environments and package management. Hey all and welcome back to SP Learning Labs. Today we are learning a very important topic for real Python projects, virtual environments and package management. Virtual environments help us to keep each project separate so our packages do not mix and create problems. Hook. Think of a chef working in many kitchens. Each kitchen has its own ingredients. If all the kitchens share the same chef, things would get mixed up and recipes would get ruined. Similarly, each Python project needs its own ingredients and chef. A virtual environment gives every project its own space. In the last module, we have learned about regex, how to find and clean patterns in text. Now we move to project setup and how to keep everything organized using a virtual environment. Virtual environments help you to create a separate Python setup for each project. Why this is needed? Different projects use different package versions. One project might need Django 3 and the other Django 4. Without separation, installing one version can break the another project. Module 1.2. Creating and managing virtual environments. For that, we'll see now. To create a virtual environment, we use open terminal first, then create a virtual environment in the command prompt. I am creating Python venv as venv. It has been created. Now to activate it, we'll create activate, and we have activated it. We can see here venv is been activated. Now we'll install packages. For that, I am installing pip install fast API. Fast API is being installed. After installing packages like fast API, we'll see version installing. For that, we are going to write pip install fast API equals to 0.95.2. That is the version name. If you want a package of a specific version, you are going to do that. We have this installed. If you want to see what are the install list, we can see pip list. We have all these installed using pip list. Now we'll use pip uninstall for uninstalling the packages. Pip uninstall fast API we can see the fast API, the version is being uninstalled. It is asking us proceed with yes or no, and we have yes, and it is uninstalled. Now pip list, we have no fast API in it. We'll clear the PowerShell now. Get a new terminal. Now we are going to see reproducibility. For that, I am creating a file with pip freeze requirements.txt. Requirements.txt is used to save all the installed packages. Requirements.txt is created, and we have all these installed in that. Now if you want to install anything from this, we can directly pip install our requirements.txt. Pinning versions is very important because different versions can break your project. We have all our installments ready. We have the install. Python exe is also installed. That's how virtual environments are created, installing packages and version upgrades are.
So, virtual environments stop these conflicts. Creating and managing virtual environments. To create a virtual environment, we use Python mvenv, env and name. To activate these, we have separate scripts. For Windows, we use this. For Mac or Linux, we use this. To deactivate, we use deactivate. People often name their environment folders venv, but any name is fine. Dependency management with pip. Inside your virtual environment, you install packages using pip. Install a package. Pip install package name. Install a specific version. Pip install package name 1.2.3. If you want to uninstall packages, pip uninstall package name. See install packages? We'll use pip list. All packages are installed only in inside virtual environment, not globally. Requirements.txt for reproducibility. Requirements.txt is used to save all the installed packages so someone else can install the exact same ones. We'll create a file. Pip freeze requirements.txt. We'll install from it. Pip install requirements.txt. Pinning versions is important because different versions can break your project. Common errors and fixes. Here are some common mistakes developers make. Installing packages in the wrong environment. Forgetting to activate the environment. Forgetting to create requirements.txt. Environment is not working on Windows because of path issues. A simple fix is always check your terminal. It should show venv before the command. More common errors. There are few more common issues. Running pip install without activating the environment installs globally. Uploading the virtual environment folder to GitHub. Never do this. Installing packages that do not match your Python version. Virtual environment not working when moving between Windows, Mac and Linux. Always activate your environment before installing anything. Never mention facts. Some useful things people rarely talk about. Pip list. Outdated shows, but which packages need updates. PyProject.toml is slowly replacing the requirements.txt in modern projects. Editable mode. Pip install E is used for development packages. Tools like Poetry and pipenv can manage environments and packages more easily. We'll see a few tricky questions. Developers often got confused with these. Should you upload your virtual environment folder to Git? No. Where do you install packages? Inside an activated environment. How do you save all these package versions? Pip freeze requirements.txt. We'll see a few interview questions. What is virtual environment? A separate Python workspace for each project. Why use it? To stop version conflicts. What is pip used for? Installing and managing packages. What is requirements.txt? A file listing all project packages. What does pip freeze do? Saves installed packages to a file. Should you commit the env folder? Never. This is virtual environment and package management. You know how to set up isolated environments and manage packages for clean, error-free projects. Next, we'll move to debugging and profiling in Python, where we learn to find and fix issues in your code. And that's how we wrap this session. If you like this video, like, share and subscribe to SP Learning Labs. Debugging and profiling. Hey all, and welcome back to SP Learning Labs. Today's topic is debugging and profiling in Python. Debugging means finding and fixing mistakes in your code. Profiling means measuring how fast your code runs and finding which part is slow. Both skills are important for writing good programs. Hook. Think of debugging and profiling like a car. If your car makes a strange noise, you check to find where the problem is. That's debugging. If your car is using much fuel, you check which part is slow or insufficient. That's profiling. Both help your car run better. The same applies to your code. In the last module, we learned about virtual environments and package management, how to set up clean project spaces. Now, we learn how to inspect our code and improve its performance. Debugging is the process of finding out what went wrong in your program. Profiling is the process of measuring the time taken by your program and finding slow parts. A good programmer knows how to both debug and profile the code. Debugging with PDB. Python has built-in tool called PDB for debugging. It allows you to pause your program and check what is happening line to line. Useful PDB commands. Breakpoint. Stop where the program here. N. Go to next line. S. Go into a function. C. For continue running. I. To show code. P variable. Print a variable's value. You can use PDB to fix problems like incorrect logic, wrong variable, values or unexpected errors. Measuring performance with TimeIt. TimeIt is used to check how long a small piece of code takes to run. It is more accurate than using time.time. You can compare two different ways of doing something. String joining versus concatenation. Code that loops versus code that uses built-in functions. You can run TimeIt for Python from the command line. Profiling code with cprofile. cprofile helps you with understand which function in your program takes the most time. It tells you how many times each function ran, total time taken by each function, time per function call. You can use it for real-world tests. Repeat. You can use it for real-world tasks like profiling a pandas, data cleaning script, or large loop. Visualization tools. There are tools that help you to visualize profiling results. SnakeWiz shows graphs. PySpy works even while the program is running in production. These tools help you quickly understand which parts of your code are slow. Common pitfalls. Some common mistakes when profiling. Leaving print statements everywhere. Misreading stats, confusing total time with per call time. Using time.time for benchmarking instead of TimeIt. Not checking where the real bottleneck is. Forgetting cumulative time includes child function calls. Profiling needs careful reading of results. Common errors. Developers also make these mistakes. Using PDB in production code. using time.time instead of timeit for accuracy, using profilers incorrectly, interrupting profiling data in the wrong way, not optimizing the right part of the code. A profiler helps you find where time is wasted, but you must read its results correctly. Never mention facts. These are some helpful tools many beginners don't know. Fault handler can show Python tracebacks during crashes. You can combine cprofile with pstats to sort results. Sampling profilers like PySpy or Scalene don't slow down your production. Profiling should be done often to keep your code efficient. These tools help make debugging and profiling easier. Tricky questions. Here are some tricky questions. Which tool is best for benchmarking? Timeit. What does cprofile show? Time taken by each function. What is pstats used for? Sorting and analyzing profiling data. We'll see a few interview questions. What is debugging? Finding and fixing errors. What is profiling? Measuring the speed of code. What does PDB do? Step-by-step debugging. What does timeit do? Measures execution time correctly. What does cprofile do? Show time taken by each function. Which tool visualizes profiling data? SnakeWiz or PySpy. This is the end of debugging and profiling. You know how to find errors, measure performance in your Python programs. In the next module, we'll learn error handlings and exceptions, which teaches you how to create safe and reliable programs. That's it for today's video. Like, share and subscribe to SP Learning Labs. Error handling and exceptions. Hey everyone and welcome back to SP Learning Labs. Today we are learning a very important part of writing safe Python programs. Error handling and exceptions. Errors happen in every program and Python gives us tools to handle them properly, so our program doesn't crash suddenly. Hook. Think of a car moving on the road. If something unexpected happens, like a dog crossing, the brakes stop the car safely. In the same way, exceptions are like brakes for your program. When something unexpected happens, the program can stop safely instead of crashing immediately. In the last module, we learned debugging and profiling, how to find bugs and measure performance. Now we are learning how to prevent unexpected crashes and make our code safe and reliable. Python gives us 4 main keywords to handle errors. Try, code that might cause an error. Except, code that runs if an error happens. Else, code that runs only when no error happens. Finally, code that always runs. Example, closing files. We can also catch multiple types of errors by writing multiple except blocks. This makes our program stable and more user-friendly. Module 1.4 Basic Try Except Examples. I am taking a try condition here. Try x equals to module 1.4 Basic Try Except Examples. I am writing a try condition x equals to int of input of enter a number. I am writing a except condition except value error. print invalid number. I am writing an else condition here. Else print you entered, comma, X. We'll take a finally print program finished. We'll run it. Here we have enter a number and I'm entering 5. You entered 5. Program has been finished. Now I'm entering an invalid number and we have ABC as invalid number. Program finished.
Custom exceptions. Sometimes we want to create our own type of error to make our code more clear. For example, invalid age error exception that will give a pass. This helps us show more meaningful error messages and makes the program easier to understand and debug.
Now custom exceptions. Here for custom exceptions they are clear errors. For that I am taking a class as invalid age error. This is exception. This is a custom exception. I am letting it pass. Now I am writing a def. Here in the try condition, try age equals to int of input, enter your age. I am writing an if condition here. If age is less than 18, raise invalid age error as age must be 18 or above. I am writing a print statement here. Print access granted. I am writing an except here, except invalid age error as E. Print custom error, comma E. Except value error, then I'm printing print please enter a valid age or a number. Finally, print program has finished. We'll save this program and run it. We have enter your age and I enter 20. We have access granted as the age is above 18. Now I am entering age 15 and we have age must be above 18. Program is finished. Exception hierarchy. Python exceptions follow a structure called a hierarchy. At the top is base exception, then exception, and then all built-in errors under it. Common built-in exceptions include like value error, type error, index error, key error, zero division error. Knowing this hierarchy helps you catch the correct error and avoid catching the wrong ones. Logging integration. Instead of using print to show errors, we use logging, which is more professional. Logging helps us record errors in files, save timestamps, help fix issues later. Logging also has levels like debug, info, warning, error, and critical. Logging is very important in real world. Now we'll see logging integration. Logging has levels: debug, info, warning, error, and critical. For that, we'll see a logging example now. For that, I'm importing import logging. I'm writing logging dot basic config of level equals to app dot log. Level equals to logging dot error. I'm taking file name as app.log. Now I'm writing a try condition. Try equals to 10 divided by 0, except 0 division error. Logging dot error division by 0. For except, I'm taking logging dot error as division by 0 happened here. I'm running it. We can see app.log is created here, and here the error is root division by 0 happened. That's how the logging is done. Logging is very important in real world because you can see what happened even after the program runs. Common errors. These are some common mistakes developers make with exceptions. Catching exception too broadly. This hides real bugs. Forgetting to use finally. Resources may never close. Overusing custom exceptions makes code too complex. Logging only after the errors instead of logging regularly. Good programs catch only the errors they expect. Never mention facts. There are some advanced things that many beginners don't know. Base exception also catches the system exit and keyboard interrupt. Be careful. Using raise from keeps the original message error. Logging.exception automatically prints the full error trace back. Do not swallow errors silently. Always log or raise them. These facts help you write cleaner and safer code. Here are some tricky questions for you. Should you always catch exceptions? No, it hides the real problems. What does finally do? It always runs, even if an error happens. How do you create a custom exception? Create a class that inherits from the exception. Interview questions for you. What is try except used for? Catching errors safely. What is finally used for? For a cleanup code. What is custom exception? A user defined error class. What does logging do? Saves error details to files. Should we catch exception everywhere? No. What is value error? When the value given is invalid. This is the end of this module, error handling and exceptions. You now understand how to prevent crashes, handle errors safely and log issues for future debugging. Next, we'll learn testing in Python, how to check if your code works correctly. That's it for today's section. If you like this video, like, share and subscribe to SP Learning Labs. Hey all and welcome back to SP Learning Labs. Today we are learning testing in Python, which helps us make sure our work code correctly before real users use it. Testing avoids bugs, prevents mistakes and keeps your project stable. Hook. Imagine a plane before takeoff. Engineers check everything carefully. They don't trust that it should work. They test it. In the same way, we must test our Python code before releasing it or using it in real projects. In the last module, we learned error handling and exceptions, how to stop programs from crashing. Now, we learn how to check if our code is correct by using automated testers. Why testing matters? Testing is very important because it prevents old features from breaking when new ones are added. It avoids manual checking again and again. It increases confidence in the code. It makes long-term projects stable. Testing saves a lot of time in the future by catching mistakes early. Unit test framework. Python has a built-in testing framework called unit test. To write tests, create a class that inherits from unittest.testCase. Write test methods starting with test. Use assertions like assert equal, assert true and assert rises. Run test using Python M unit test. Unit test is the basic and official testing tool in Python. Module 1.5. Python has a built-in testing framework called unit test. For that, we'll see with an example now. Unit test. For that, import unit test. I'm taking a class here, class test math of unit test dot test case. I'm writing a def here, def test add of self. Self dot assert equal. Here I am adding it, so add 2 plus 3, 5. If name equals to main, then we'll take it as unit test dot main. I'm running it and we have ran one test in 0.00 seconds and it's okay. PyTest basics. PyTest is a simpler and more powerful testing framework. Its advantages are: tests can be written as normal functions. Assertions use simple assert. PyTest automatically finds and tests files. It supports fixtures for setup and cleanup. Supports parameterized tests to test many inputs easily. PyTest is very popular because it is easier and cleaner. Mocking and monkey patching. Mocking is used when the code depends on the things outside of your program. For example, APIs, databases, network calls, reading files. Instead of calling the real API, we use a fake response during a test. This makes tests faster and safe and also consistent. Monkey patching allows us to temporarily change behavior during tests without modifying the real code. Here is a simple mocking idea. These are for instead of calling the real API, we use a fake response during tests. That we'll see with an example now. Mocking is nothing but fake data for testing. For that, I am taking from unittest.mock. I am importing patch. For now, this import requests. @patch requests dot get. Def test API. As this is a mock, we are going to take mock get. Mock get dot return. I am returning return value dot status code equals to 200. We know what error it is. Assert mock get dot return. Return value dot status code equals to 200. We are now installing pip install requests. Now pip install PyTest and then we'll run it. PyTest and the file name. We have our output, 1 passed in 0.18 seconds. That's how unit test is done using mocking. Best practices for our maintainable tests. Good tests must be independent. Each test should run on its own. Clean, easy to read, reusable, use fixtures for repeated tasks. Consistent, tests should give the same results every time. Measured, use coverage tools to know how much code is tested. These practices help large projects stay organized. Common errors. Many beginners make these mistakes. Making tests depend on each other. Not cleaning up resources like files or databases. Mocking too many things. The test becomes unrealistic. Ignoring flaky tests. Using print instead of assert. These errors make tests unreliable and hard to maintain. We'll see few never mentioned facts. These are some important things people don't usually talk about. PyTest can auto-discover test files without extra setup. The hypothesis library can generate random test inputs into automatically. Coverage tools show which lines of code are you interested. You can combine mocking, fixtures and parameterization. Tests should not be slow unless necessary. These facts make testing more powerful and flexible. We'll see few tricky questions. What should tests avoid? They should avoid depending on each other. What is mocking? Using fake objects in the place of real ones. We'll see few interview questions. What is unit testing? Testing small parts of the code. What does assert do? Checks if a condition is true. Why use PyTest? It is simple and also powerful. What is mocking? Replacing real objects with fake ones for testing. What is code coverage? Percentage of code is tested. This is the end of this module, testing in Python. You now know how to write tests, use unit tests and PyTest, and follow best practices for clean and maintainable test code. In the next module, we begin a deep topic, concurrency and threading and async in Python. That's it for today's session. Like and share. Subscribe to SP Learning Labs. Hey all and welcome back to SP Learning Labs. In this module, we are learning one of the most powerful concepts in modern Python, asynchronous programming using async. Async IO allows your program to run many tasks without blocking, which makes it perfect for handling large number of web requests, network calls, file operations and background tasks. By the end of this module, async IO will feel simple and logical. In the previous module, we learned threading in Python, how threads run tasks in the background, where they help and where they struggle with CPU heavy work because of the GIL. Async IO is closely connected but works very differently, and today we'll understand it with very easy examples. Imagine you go to a hospital for blood test. The nurse takes your blood sample and says it'll take 20 minutes to process. You don't stand there doing nothing. You might check your phone, reply to messages, drink water. You're not blocked. You continue doing other tasks while the lab is processing your sample. This is exactly how async IO works. Your program does not sit idle. It continues doing other tasks while waiting for something to finish. Coroutines and tasks. Let's begin with basics. A coroutine is simply an async function. You define it using async def mytask. To run it, you use await. Coroutines and tasks. That we'll see with that example now. I am importing async IO, async def greet. I'm writing a print here, print hello from coroutine. Async def main. I am writing await greet. Async IO dot run of main. Await is like saying pause here until this task completes and then continues. We'll save it and run it. And we have our output hello from coroutine. Here from the main, it goes into this main and runs. A task is just coroutine that runs in the background, created like this. We'll create tasks. This will be a background execution. For this, I am importing async IO, async def work, print working. Coroutines are async functions, but tasks are async functions running in background. I am writing async def of main task equals to async IO dot create. We'll create a task of work. Await task. Async IO dot run of main. We'll save this and run it. And we can have our output as working. This will create a task and assign it, and it waits, and it will run in background, and it will show our output as working. It continues these coroutines are the heart of async programming. They allow your program to pause, wait, and continue later without blocking everything else. You put rice in the cooker. It cooks on its own, and you continue cutting vegetables. You don't stand there waiting. Event loop. The event loop is like the manager that controls all the async tasks. It decides which coroutine runs now, which coroutine should wait, when tasks should resume. Think of it as a traffic controller guiding vehicles so they don't collide. You normally don't control it directly. Python runs it behind the scenes. For example, when many people are waiting at the bank, the manager decides who goes next. That's an event loop. We'll see loop behaviors now. we'll see a small demo of event loop behavior. For this, I'm importing async IO, async def of task 1. I'll be printing print task 1 is started, task 1 start. We'll make it wait. Await async IO dot sleep of 1. Print task 1 end. I'm writing another task, async def of task 2. I'll print task 2 start. Await async IO dot sleep for 1. Print task 2 end. Async def main. I'm writing an await async IO dot gather of task 1 comma task 2 comma task 2. Both tasks interleave showing event loop cooperation. Async dot run of main. We'll see the output now. Here we can see task 1 have been started, then it goes to sleep, then task 2 is also started, then task 1 ends and task 2 also ends. Async with input outbound as YNCIO. Async shines when handling many input and output tasks, especially network related tasks. For example, you need to scrape 100 web pages. With normal code, you fetch one page, wait, fetch next, and then wait. But with async, you can fetch many pages at the same time without blocking. Now we will see async IO with async input and output. For example, we'll fetch 3 URLs concurrently. For that, I'm importing async IO, async def fetch, print f fetching n. I'm writing an await here. For this, all the 3 tasks wait at the same time. Massive speed improvement. Await async IO dot sleep of 2. I'm printing print done of n. I'll write another async def of main. I am giving tasks equals to async IO dot create. We'll create a task. So create task, fetch I. I'm writing a loop here. Loop for I in range of 1, 4. Let's write an await async IO dot gather start task. We'll run it. Async IO dot run of main. They wait at the same time. We can see it. Fetching 1, fetching 2, fetching 3. They have waited for a while and done 1, done 2, done 3. This is because we have given here to wait for 3 times. It fetches through it and fetching 1, fetching 2, fetching 3. Then it waits for 2 seconds. Then it will be like done 1, done 2 and done 3.
Common mistake that beginners do. Using time.sleep inside an async code. This blocks everything. You must use await async.sleep, forgetting to await. If you don't await a coroutine, it never runs. Mixing blocking code with async code. If you add normal blocking operations inside an async code, the whole async system slows down. Async code must stay cooperative, meaning each coroutine must give time to others using await.
We'll see profiling and debugging in async. For this, I'll take a simple time profiling. For that, I'm importing import async IO, comma time. Async def of task n, await async IO dot sleep of n. These are mainly used tools like cprofile, async profiler, logging, async def main. Await of async IO dot gather. Task 2. And I'm taking another one, task 3. Start equals to time dot time. Async IO dot run of main. End equals to time dot time. We'll print enter start. We'll save this and run it. Time profiling happens and we have our output. This shows like how much the time is taken to run this, the start time and the end time. The gathered, the task while running task 2 and 3, and we have our output.
Common errors using time.sleep inside an async code. This stops the entire event loop. Forgetting await. If you forget to await, the coroutine never gets executed. Mixing sync
and async libraries incorrectly. For example, using a normal request library inside an async code that blocks everything. For async, you need async friendly libraries. Blocking the event loop. If one coroutine does heavy work, it prevents other from running. Async should only be used for tasks that wait for something, like input-output toss. Never mention facts. There are some truths most tutorials don't mention. Async functions don't run at the same time. They switch time cooperatively using await. The event loop never preempts tasks automatically. Coroutines must willingly give time using await. Async tasks don't start automatically. You must either await them or convert them into tasks. Exceptions inside tasks must be handled carefully. Otherwise, errors can be invisible. Async I/O is not replacement for multiprocessing. It only helps input-output bound problems. These points help you understand async at a deeper level. Practical guidelines. To keep async code simple. Don't use async unless necessary. Start small, then optimize. Avoid mixing threads and async unless required. Always handle exceptions inside the async tasks. Keep coroutines small and predictable. Test async code with logging and monitoring. These guidelines help avoid confusion. There are few practical guidelines that we need to follow. For that, we'll take a small example called save task. For that save task, I'm importing import async IO, async def, save. I'll write try, then await async io.sleep for 1. We'll raise it, raise value, error. We'll write a value error here, raise value error, something went wrong. Then I'm going to write except, exception as E. Exception as E. We'll print error as E. We'll save this and we'll run it. Async io.run of save. And there we go. We have our output error, something went wrong. As we have seen here, we have printed that E, and if it's not correct, we raised a value error and we have our output. We'll have few mistakes like CPU task in async. When concurrency happens, this mistake always happens. For that, I am taking an example. Import async io, async def, fetch of I, I'm writing a print here, print start task I. the tasks are many, we'll take I. Await async io.sleep of 1. We'll print end task of I. Will return I. And I'm writing async def of main task equal to async io dot create task of fetch I. Fetch I. I'm writing a loop here for I in range of 5. Results equals to await async io dot gather tasks. We'll print the results. Results. We'll save it and run it now. Async io.run of main. Running it, and we have, as the range is up to 5, we have our start task from start tasks and end tasks, 3 and 2 and 1, and we have our result from list 0, 1, 2, 3 and 4, as our range is up to 5. Async is powerful, but it needs discipline. That's how we complete our async.
Few other facts. Async IO is not faster than multiprocessing for CPU work. Too many async tasks can overwhelm your program. Logging and tracing async tasks is essential. Async debugging is harder when blocking code is mixed in. Async helps reduce resource usage compared to threads. Event loop keeps the program alive until all tasks finish. They help you understand why async behaves the way it does. Few tricky questions. What is a coroutine? A function declared with async that can be paused and resumed. What is an event loop? The scheduler that manages and runs async tasks. Why can't we use time.sleep in async code? Because it blocks the event loop. When use async IO? For input-output tasks involving lots of waiting. When use multiprocessing instead of async? For heavy CPU work. What is biggest mistake in async programming? Mixing blocking code with async code. Do async tasks run in parallel? No, they run cooperatively unless combined with threads or processes. And that completes our clear and simple async and asynchronous programming in Python.
Now you understand what async functions are, how await works, how the event loop and run tasks, common mistakes, and many more. How async compares to threading and multiprocessing. In the next module, we'll explore something extremely important for optimizing Python efficiently: memory management and garbage collection. We'll learn how Python stores and frees memory, how the garbage collector works, how memory management leaks, and how to write memory efficient programs. See you in the next video. That's it for today's session. If you like this session, like, share, and subscribe to SP Learning Labs. Hey everyone, and welcome back to SP Learning Labs. In the previous module, we learned the foundational ideas of async IO, coroutines, the event loop, async IO, common beginner mistakes, and why async shines in input-output heavy tasks. Now we'll go one level deeper. This module focuses on two things. 1. Common mistakes developers make when writing async code. Advanced async IO features that help build reliable real-world async applications. This will complete your understanding of async IO at the intermediate level. 1. Using blocking code. A critical async mistake. One of the biggest challenges beginners face is accidentally mixing blocking code inside the async functions. Why blocking code is dangerous? Async IO works only when the event loop is free to schedule tasks. If one function blocks the loop, everything else freezes. Now we'll see an example for it. This stops the entire program for 3 seconds. No coroutine can run during this time. Correct async friendly version. This allows other tasks continue while waiting. For example, if a cashier stops billing because they want to check their phone, the whole queue freezes. But if they check their phone only when the queue is empty, everything flows smoothly. Second one, forgetting await. This one is the simplest and most silent mistakes. For example, this does not run the function. It only returns a coroutine object. The correct version is this. If you forget await, nothing runs. But Python doesn't warn you. This makes it tricky for beginners. Third one, mixing blocking libraries with async code. Some libraries were designed before async existed. For example, requests, blocking database drivers, blocking file operations. When used inside async code, they freeze the event loop. Wrong. But we can possibly fix it with using AIO HTTP, async version, or offload blocking code to a thread. Await loop.run in executor. None. Request.get URL. For example, it's like attending an online meeting while downloading a huge file. If your network is slow, everything freezes. To avoid this, you separate heavy tasks from sensitive ones. Overusing async. Not every problem requires async. Sometimes normal synchronous code is faster, clearer, easier to maintain. Async IO is best only when you deal with tasks that wait, like network calls. If the task is mostly CPU work or simple local operations, async can make the program unnecessarily complicated. Deep debugging facts most people don't know. Here are hidden truths that help diagnose async issues. Async io.to thread runs blocking code in another thread safely. ANYIO, a library that provides a unified async API compatible with Async IO, Trio, and Curio. Async IO debug mode, enabling debug logs. Python async IO debug equals to 1. This reveals slow coroutines, blocking calls, unawaited tasks, cancel tasks. Very useful for real-world debugging. Synchronization primitives, locks and semaphores. Async tasks sometimes need controlled access to shared resources. Async IO provides async io.lock, async io.semaphore. Example with lock. It has a safe access. Locks prevent race conditions, situations where two tasks modify the same data incorrectly. Semaphores. Semaphores limit how many tasks can do something at once. For example, only allow 5 concurrent API requests to avoid rate limits. For example, a parking lot with only 10 slots. Only 10 cars can enter. Others must wait. Async context managers. You can use async with to manage async resources. For example, async with AIO http.client session. As session, this ensures proper cleanup even if the coroutine crashes. Like a hotel room keycard that automatically turns off electricity when you leave. Async iterators and async generators. Async iterators allow you to loop through data that arrives slowly or in paths, like streaming APIs. Async for item in stream. Async generators let you produce data gradually using yield. These tools help build efficient streaming systems. For example, reading log files in chunks, streaming chat messages, downloading large files piece by piece, running blocking code safely with executors. Some work is too heavy for async to handle directly, like CPU heavy tasks. To avoid freezing the event loop, you can run such code in an executor. Like this. This moves heavy tasks to a thread pool, like image processing, video encoding, machine learning interface, heavy file operations, real-world async mini projects. Here are some practical async applications. Concurrent web scraper that scrapes 100 plus pages at once using AIO HTTP. Save results into a .csv. Async API client. Build a client for GitHub, weather, or crypto APIs. Fetch many endpoints together. Chat simulation. Simulate multiple users sending messages asynchronously. Async downloader. download multiple files, PDFs, images, videos all at the same time. These projects show how async I/O drastically improves performance when working with I/O heavy workloads. Few tricky questions. Why does time.sleep break async? It blocks the event loop. What happens if you forget a wait? The coroutine never executes. Why use async.io lock? To prevent race conditions between async tasks. Why use async io.semaphore? To limit concurrent operations like API calls. Why use run and executor? To offload CPU heavy tasks without freezing the event loop. What is an async generator? A generator that yields values asynchronously over the time. What is the advantage of async context managers? Automatic cleanup in async workflows. And that completes this module, the final piece of our async I/O. By now, you understand advanced async tools, how to avoid common async mistakes, how to control concurrency safely, how to stream and process data efficiently, how to run heavy work without blocking async, how to build real-world async projects. In our next module, we'll cover something extremely important for real-world Python development: memory management and garbage collection. We'll explore how Python stores objects, how memory is allocated, how garbage collection happens, and how to avoid memory leaks. See you in the next module. That's it for today's session. If you like this video, like, share, and subscribe to SP Learning Labs.
Keywords and Libraries Part 1. Hey everyone, welcome back to SP Learning Labs. Today we are diving into that is keywords. These small words like if, for, class and try are the soul of Python. They tell your program what to do, when to do it and how to react. By the end of this session, you will not only know what keywords are, you will know how to use them with confidence, clarity and pro-level understanding. In our previous video, we explored how to install Python across operating system like Windows and even advanced setups using Pi environment and Anaconda. Now that your Python is fully installed and ready, it's time to understand how Python actually talks. And that conversation begins with keywords. Let's begin with the big question: what exactly are keywords? Think of Python as a language. Just like English has grammar rules, Python has keywords. These are reserved words, meaning Python has already assigned a fixed meaning to them. So you can't use them for naming your variables or functions. For example, if equals to 10. It's an syntax error because Python immediately says, sorry, can't do that. That's my word. Keywords are like road signs for your program. If means checking a condition. For means looping a condition. Try means handling an error. They shape the logic in every single piece of Python code you will ever write. Keywords and libraries. Here's a fun fact. Python only has around 35 keywords, yet companies like Netflix, Google and even NASA build massive systems with them. Small list, massive power. Let's unblock that power. What are keywords? Keywords are special words that Python understands automatically. They form the basic structure of your code. Example, if true, print Python understands me. Here, if tells Python that, hey, check this condition. And because if is a keyword, Python knows exactly what behavior to apply. The mistakes to avoid are never use keywords as variable names. Example, 4 equals to 5. It's an syntax error. And now think of Python as a strict teacher. Keywords are command words like sit, write, speak. If you name your pet sit, imagine the chaos every time you call it. Now, just quickly launch your Jupyter notebook. Just open that and now go to the file and open Jupyter notebook. So now I'm going to rename the file module 3.1. So now let's keywords. So I'm just going to give example. So let's take an example of if true. I want to make it big so that you can see easily if true. Now print Python understands me. So here if tells the Python, hey, check the condition. So because here if is a keyword where Python knows exactly what behavior to apply here. So now using if else. So let's take an example for that. Age equals to 20. Give the condition if age greater than or equals to 18. Print you are an adult. Now let's give else statement. Else print you are a minor. Now let's close the brace. Let's run. So here we got an output of you are an adult because we have given age equals to 20. What the condition it is going to check, age should be greater than or equals to 18. Then it is going to print you are an adult. Here age is 20, so which is greater than 18. So you got an output which is you are an adult. Okay, let's go for an example. Next, looping concepts using for loop. Let's take an example of for loop. For I in range of 3, print loop, comma, I. So now I just want to call the I values. Let's close the brace and let's see the output. We got loop 0, loop 1, loop 2. Here we have given the range 3 which is 0, 1, 2. So for I in each 3 values it is going to print that I value. So loop 0, loop 1, loop 2. Keywords versus identifiers. Let's make this super clear. Keywords are reserved by Python. Identifiers are created by us. Keywords have fixed meanings, where identifiers where we can decide their meanings. Examples for keywords: if, else, for. Examples for identifiers are X, score, username. If keywords are grammar rules, identifier are your vocabulary, the words you create to express your ideas. Categories of keywords. Python keywords fall into categories. Let's explain them. The logical keywords are and, or, not, is, in. These are used for logic and for comparisons. Conditional keywords. Those are if, elif, else. These are used for decision making. Looping keywords. For, while, break, continue, pass. These are used for looping and flow control. Exception handling. These are try, accept, finally, raise, assert. These are used to manage your errors. Functions and scope. Def, return, global, non-local. These are used to define your logics. Oops and classes. Class and delete. These are used in object-oriented programming. Modules and imports. Import, from, as. These are used to import your libraries and comes into boolean and null. True, false, none. These are used for logic values. Context managers and generators like with, yield. These are used in file handling and generator functions. Async programming. Async and await, where you are going to use for concurrency. Together these 35 keywords define the entire grammar of Python. Why keywords are needed? Imagine writing a story with no grammar, just random words. That's what Python would look like without your keywords. Keywords make code structured, readable, and predictable. They tell Python where conditions begin, where loops run, when functions start, and when execution stops. Keywords are like Lego connectors. Without them, your colorful blocks that your ideas have no way to stick together. Let's go for an example, other example for try accept. Using try and accept. Now give try x equals to 10 divided by 0. Then accept zero division error. Now let's print. Oops, division by division by 0. Sorry, by 0. Let's close the brace. And now finally, let's finally print execution complete. Let's close the brace and let's run the output. Oops, division by 0, and we got execution complete. So here we are going to see the try. If there is an error in try, then on it is going to print accept, and then whether we have an error or not, it will print finally block. So here 10 by 0 we have an error, so we are going to print the accept block, which is oops division by 0, and finally it is going to print the finally block, which is execution complete. So now let's see class defining. So let's see defining a function. So now let's take def greet of name and return. Use formatting string f hello, comma, open the curly brace and name, and just close that, and let's print the statement. We have to follow the proper indentation here. Greet of Keywords and Libraries Part 1. Hey everyone, welcome back to SP Learning Labs. Today we are diving into that is keywords. These small words like if, for, class and try are the soul of Python. They tell your program what to do, when to do it and how to react. By the end of this session, you will not only know what keywords are, you will know how to use them with confidence, clarity and pro-level understanding. In our previous video, we explored how to install Python across operating systems like Windows and even advanced setups using Pi environment and